Hi everyone, it's me, Carolyn, and in this video we're going to be talking about the standard normal curve. It's kind of like the basis to all other curves, and so we need to have a really good understanding on how to work with this curve. I prefer to use, or I will be showing you how to use the tables for this. There are technologies out there that will do a lot of it for us, but I also see value in learning how to read tables, whether they be this table or some other new table to you. So it's just kind of a learning curve. I'm going to start by sharing my screen so that we can look at the guided notes that I have. You will have to ignore my cat. His tail tends to be swishing here as he decided he wanted to sit with me. Hopefully it's not too big of a distraction. I'm hoping he leaves shortly, but we'll see. That's his tail kind of flipping in there. So maybe you might think it's comical. But this is section 7.2, and I did break this into two pieces. This first part, we're just going to look at that standard normal curve. So some of the properties, first of all, it is symmetric about the mean, as all normal curves are. This one in particular is kind of man-created, does not have a certain situation that follows it. Its mean is going to be 0. And its standard deviation is 1. So when you draw it, again, just kind of reminding ourselves the normal curve is nice and symmetric. It is centered around the mean, so that 0 is kind of in the center. I kind of include that here in the second one. The mean, the median, and the mode are all 0. The mean, the average, the median, the middle, and the mode, the most common, the highest point, all do occur at z equal to 0. We like to use the letter z to represent our standard normal values. So those z values are going to be the ones that lie on this axis here. Our inflection points for this normal curve happen to be at both plus and minus 1. You can remember that the inflection points are where it changes from bowl face down to bowl face up. They are one standard deviation in either direction from the mean. Since our standard deviation is 1, they happen at 1 and negative 1. The total area under the curve is 1, but again, that is because it is a normal curve. It is a probability density function, and that is one of the rules that we have for those probability density functions. Other things to kind of keep in mind, if you take the area under the curve from here on up, it's also the same as the area from here on down. Since it is nice and perfectly symmetric, those two halves are equal, and they are exactly 1/2. So because the total area is 1/2 of it would be 1/2. Some other things, as z increases this direction, our curve is going to come down and approach 0. It does so rather quickly. Also, as it decreases, goes in the negative direction, it also approaches 0. Never gets there, but it gets very, very close very, very quickly. And the last little property we have is that the empirical rule does hold. So that 68, 95, 99.7 rule, those approximations do hold. Now, we're going to be learning how to find probabilities based on this standard normal. And again, I will be using the letter Z to represent our standard normal. So the first one I'm going to do is we're going to find the area to the left of Z equal to 1.33. This is going to be the same as asking what is the probability that Z is less than 1.33, or we could also have less than or equal to, because you can remember that the value or probability of a single value when we're talking about a continuous scale will be 0. I also like to draw pictures to kind of help me with these pieces. So again, we're dealing with the standard normal, which is centered at 0. 1.33 will be on this side of it. I don't spend a lot of time making sure I'm precisely 1.33. For me, it is more about, am I above the mean or below the mean? And then we want to go to the left. The left is this direction. So also reminding smaller than is going to be on our left side. And the way this works is we're going to be using a table. And the table that our textbook has is not the same table that is out there always. There are usually 2 different tables that you can find online. And there are 2 sides to this, or 2 pages to this. And what we'll see is you'll have our Z values. Those are the values that are along that axis down here. And they start at about a negative 3.4 and they range all the way up. And I'd have to flip it over to the other side to get my positive side here. You'll also kind of see the picture when we're on the positive side, we have that Z above the hump. And when we're on the negative side, Z is below that hump. So that kind of helps remind me, remembering that it is centered at 0. Okay, you will also see some values going across the top. Now, there are also tables out there that are much more detailed than this. So just kind of make sure if you do find some table that you're using off the internet that it kind of matches the one you're comfortable with. All right, so we are trying to find the area from 1.3 down. So I'm going to go on my positive side and we're doing 1.33. So the way this works is this values, they give us our first digit in the decimal. So there's my 1.3. To get that second 3, we're going to get our hundredths position by going across the top. So this would be 0, like 3, 0, 3, 1, 3, 2, 3, 3. So we're going to go down here and pull that value right there. So that 0.908. 0.9082. And that would be the probability that our value is below that. It would be the area under the curve. So both of those meetings. Let's do a few more just so we get comfortable using this table. So again, we want to find the area left of 2.74. Again, I like to draw pictures because they help me. 0 is in the middle. Z, 4 is on this side. Okay, so I need to look up that 2.74. It is a positive, so I want to be on the positive side. My 2.7 is down here. So I went down to find 2.7. And then we're going to go over to the 0.4. So I kind of have to make sure that I hit the right one. 0.04 coming down, 0.9969. 0.9969. We're going to do one more that goes to the left. Just make sure we've got this down. Okay, so get a picture. There's my 0. Negative 1.86. This is 0, so negatives are on this side. Negative 1.6, and we are going this direction. Now, just kind of keep in mind, too, with that one rule that said the bottom area and the top area, so these halves are a half. So that's why we did get up here larger than 0.5. Here, we should get something that's smaller than 0.5 because we're down on this little bitty tail. Now, we do want to make sure to look on the negative side. So negative 1.8, and I'm going over to the 6. Okay. See if I can get that to show up in here. Negative 1.86, 0.0314. 0.0314. Okay, we're going to do a couple more areas, but now we're going to switch and look at the right. So I'm gonna go drag in my picture. Always draw my pictures with the normal curve. And I'm going 1.72, which is over here, 1.72. Always label my mean for the problem. So if we're doing the standard normal, which is Z, we're talking about the mean of 0. I go greater than right. Okay. I am going to still look up this 1.72. 1.7 will go over to 2, and that gives me 0.9573. Look up. That gives me 9573. 957. Okay. But our table always gives us the area to the left. So the area from here all the way down is 0.9573. To find the area from here up, we have to remember that our total area is 1. So this is when we would do something like a 1 minus that piece. So subtracting that from 1, get 0.0427. And again, you shouldn't realize that this is not the correct answer because this is smaller than half. And so this one makes a little bit more sense. Okay, we're going to do to the right of a negative 0.3. There are other methods for getting these. We can use the idea that it is symmetric. So I could have flipped this over and then looked up the negative 1.72. And this one, if I had looked up negative 1.72, I would have seen that 0.0427. I tend not to do that too often because I like to work with the number that I have and use the idea of the 1 minus because it is not an idea that's new. We've seen it in the past when we're looking for like one piece, but we knew all the rest. So, all right, but here we got negative 2.89, 2.89, and going to the right, or we're looking for bigger. So I'm going to look up that negative 2.89 on my table. Making sure I'm on the negative side. 2.8, and we just slide all the way over. And I get 0.019. But again, that's from this point down. So to find from that point up, we do 991. I could have looked at the 2.8 and used some symmetry, but again, I like to use the number that I'm given. Okay. And also kind of reminding how this table works. There are tables out there that give you the area from the 0 or the middle to your Z value. And then you have to work with symmetries as well. I particularly like this one because it's always from that point to the left, from that point to the left. And if you want to go from that point to the right, it's a 1 minus. Okay, here we're trying to find between. And so I'm putting my 0 in there. So I'm going between a negative 2.16 and point. Again, where you draw these, it's just for reference. So you can kind of get a picture. Again, I always put the 0 in there and then referencing those values on either side. So the negatives are to the left, the positives are to the right. Okay. What I need to do is I'm going to have to look up both of these values. Okay, I can't like subtract them and work with that because this curve is not perfectly linear. It's not perfectly flat. I need to look up both of those values. I'm going to look up at negative 2.16 and I'm going to look up at 0. Using my table. So my negative 2.16. That is 0.0154, 0.0154. And I need to look up 0.28, and that's a positive, so I'm going to flip the page over. And that's kind of towards the top, so 0.2, not like 2 point, but 0.2. 0.6103. Let me get some colors off here for us, just to kind of help us see it. So this is the area from here in this direction. So 0.0154. This number is the area under the curve from here down. So this is my 0.6103. So to find the area between, what I'm going to do is take this big area and get rid of the tail. So I'm going to take that 0.6103 and I'm going to subtract 0.0154. And I am going to use my calculator here just because I don't want to make a silly mistake. And I come up with 0.5949. Now that would be the probability of a value being somewhere between negative 2.16 and 0.28. We will see in my next video some applications. So some of this will start make more sense because right now Z is this arbitrary curve. It doesn't have some logical meaning behind it. But we will make the connection between any normal curve, which may have some physical meaning, and this standard normal curve. But that's in our next video. But I do want to keep going because there are some other aspects that we need to talk about in this curve. And I do want to kind of show you that 95% and that empirical rule does hold, or where those numbers kind of come from. Okay, so I'm going to draw my curve, and we're trying to find the area between 0, and we're going from negative 2 to 2. Okay, now remembering that the standard deviation is 1, so we should have 68% here, 95% here, and if I went to negative 3 and 3, 99.7. Now these numbers are approximations. Our table that we have, those values are much more accurate. But again, I'm going to do this one very similar to the way I did this one. We're going to look up the negative 2 and we're going to look up 2. All right, so if I look up a negative 2, that would be like a negative 2.00. So that's 0.0228. 0.0228. I'm also going to do that for my positive 2. My positive 2. And that's 0.9772. 0.9772. Okay. Again, using my colors to kind of help us. The table gives us from that point to the left, so 0.0228. And from here down is 0.9772. I want between the two. So I kind of want to go from here to here. So that means I need to take the big one and get rid of that. So we're going to take the 0.9772 and subtract off 0.0228. And if I do that, I come up with 0.9544, or roughly 95%. Now, the empirical rule is rough. They're not going to be exact values, but they are very close. So that 95% is rounded to the nearest whole. The 68% is rounded to the nearest whole. The 99.7, we do go that one extra digit because if I rounded to the nearest whole, we get 100%. But these tables go on forever and ever. So there's some people out there, we can't forget them. Just a very small amount. Okay, so this is kind of finding areas under our curve. Kind of keeping in mind, these numbers on the edge are the z values. They correspond to the values on the axis. The values in here represent areas to the left. In these next few pieces, we're going to kind of be going a little bit backwards, because sometimes we want to know the z value for certain areas. Okay, so first of all, just some notation here. Sometimes we are interested in a little bitty small area to the right or to the left. What we are going to do is we let this alpha, so this is another Greek letter. And it is alpha, so it's like the Greek letter A. You may have seen that, kind of like a fish. And it actually just is the area to the right. So when we write something like Z alpha, we're looking for the Z value that has that area to the right. Okay, so for example, we're going to do a couple of them. We want to find Z 0.05. So as a picture, okay, now 0.05 is small, and that's where you kind of have to keep in mind where we're drawing. So kind of remember this is 0. The area above is half, the area below is half. This 0.05 is a lot smaller than half, and it does represent area to the right. So we're looking here. I'm going to draw just a little tail. Area is equal to 0.05. And we're looking for that Z value. Looking for this Z value. Okay, so the way we have to rework this is going to be a positive number. Now, if we had an area that was bigger than 0.5, we would have been down here. So you kind of have to use your knowledge and skill to realize that 0.05 is going to get smaller than 0.5. So we're on this side. If we had an area bigger than 0.5, we would have been down here. Okay, so now we're going to have to think. That means we're going to be looking for a positive value, so I'm on the positive side. But remembering also that this chart is the area to the left. So if this is 0.05, this stuff here is the rest of it. So here's 5%. This would be 95% or 0.95. So what I'm going to do is I need to look in my areas, so areas in here, for 0.95. And I want to get as close as I possibly can. So here's a 0.94. Here's a 0.95. I'm getting close. Here's a 0.9505. Now I would choose the Z value that is the closest. Okay, these two are equally spaced. So I will actually just take halfway between them. So this is like 1.6, and this is 4 and 5. So halfway between gives me 1.645. There are technologies out there that will do this to a much more accurate degree. But in this video, we're going to just concentrate on getting used to this table. and how to manipulate it and how to use it. Okay, let's do this again. So we're going to have z.1. So 0.1, my curves do get a little bit lopsided when I draw them freehand. Okay, 0.1 is the area to the right. It's kind of weird. It will make sense in future chapters why we have that alpha as a positive side of z. So that's giving me the area here is 1, and looking for is z. We're looking for the z. Okay, table goes to the left. So this is 0.1, this is going to be 0.9 on this side. So I'm going to be looking inside my table, looking in my areas. These are areas for that 0.9. And I'm kind of just glazing here, and here's a 0.903 getting bigger, so I better back off. 907, 8925, 8944, 97, 1015. The one that is closer to 0.9, which corresponds to 1.2. Other ways we can do similar ideas, similar questions, but different. We are going to try to find two z values that bound a middle area. And that 0.8 could be any number that you want. But what we said is we're trying to find two values that bound a middle area. So we want to be symmetric. So we want two values, one on this side and one on this side. Symmetric. My picture is a little off. We're looking for these. And since it is symmetric, one's going to be negative, the other one will be positive, same value, because it is beautifully symmetric. But I want this middle area to be 0.80. Okay, so remembering that the table always gives us area to the left of something. This is a middle area. It's a little bit harder to figure out. So what we are going to do is if there's 0.8 in the middle, that means these two ends, so our two tails combined, is 0.2. And I got that by taking 1 minus my 0.8. But now it is perfectly symmetric. So one tail is 0.1. I got that by taking my 0.2 and dividing it in half. So this area here is 0.1. This area here is 0.1. Okay. I'm going to go for this guy down here, which could be a negative. So I'm going to be looking for 0.1 inside my curve. All right, so 0.1. Let's see. That's a little bit. 0.8, there's a 0.09, it's a bit smaller. 1, 3, 1, 2, 1, 0, 9, 3. 0.1, 0, 3. 0.0985. Again, we want the one that is closer, so we're going to go with this one, which is a negative 1.28. Negative 1.28. Since it is symmetric, this is also 1.28. And yes, if I had looked, it is the problem we had just done. I still went through the table so that you would see the work instead of just referring to one you'd previously done. Okay. All right, another way that you can word a question where you're looking for a Z value is something that says what Z would represent the 25th percentile. So that brings back what in the world does percentile mean? Again, if we're looking at our standard normal, just centered at 0. Percentile means that many people scored at or below you, right? So 25th percent is the same as 0.25. So we want to have an area of 0.25 to the smaller of us or left of us. Okay, so an area of 0.25, if I got here, that's 0.5. So 0.25 is going to be somewhere on this side. It's not going to be in the middle because this is not symmetric on the side. It does curve, even though my graphs don't look that way. So we're looking for this box, and this area is 0.25. And it should be a negative value because 0.25 is less than 0.5. And if you tried to find 0.25 on the positive side, you would never find it, because the smallest we get is 0.5 and it just gets bigger. So we would have to flip it to the negative side. And I'm looking for 0.25. Some 2's in here. Here's a 2, 4. But bigger than 4, 5, 2, 4, 8, 5. So it's going to be somewhere between these two. So 2, 5, 1, 4 and 2, 4, 8, 3. This one is 17 away. This one is 14. So we're going with this one, the one that is closer, which is a negative 0.67. Negative 0.67. And there you go. So now we have learned how to, given a Z value, find areas, or given 2 Z values, find areas between, or given an area of a certain shaded region, left or right, or strapping the middles, we can find Z values. Okay. One thing we cannot do is you cannot have and find Z values if it is not centered. Because then you could just play and shift it either direction. So if you're going to be finding between 2 values, we will be going symmetric on both sides. So just kind of keep that in mind. Okay, so that gives us an introduction to, I'm going to stop sharing here, an introduction to the standard normal. In the next video, I'm going to take that standard normal and we're going to kind of look at just in general, if I have a normal situation, something that follows our bell curve, which a lot of things do, how do I find probabilities that a person weighs between two different values, or weighs more than this, or will live longer than this, or not live as long, or the battery life of a battery, how long does a light bulb last? All those types of questions, a lot of them do follow a normal curve. So how do we get at those kind of answers? And that's going to be in my next video. So I will see you in the next video.